Welcome to the lecture series on object oriented analysis and design. So far we have done 4 lectures, this is the 5th lecture, and what we have understood in the process is the fact that to address more complexity in terms of a puzzle, in terms of a problem, in terms of a program or a software, we need to understand that we have to build some from the scratch, we have to use some which are already available. One paradigm that is helping us build certain things which we need to build and use certain things which are already existing, both together in a manner where we are able to stand the question saying that is it working. That technology is what we call object oriented analysis and design. Again, it is not a silver bullet, it is not a magic solution. Where it works, it has been working wonders, and we know for sure that if you are talking about building a complexity, let us say something like 1 lakh lines of code, it is very likely that you will use this paradigm object oriented analysis and design, provided you know how to spot the objects, you know how to model the objects in terms of which objects connect to each other, and you have a method of blending the top down and bottom up in terms of cohesion, in terms of coupling, in terms of communication, in terms of reusability, data encapsulation, inheritance and polymorphism. You see, we suddenly have a dozen new terms to talk about this idea of technology. Well, at the core we owe our progress to what is called the structured programming paradigm, or it is always true to tell that it is not correct to think that one technology will wipe out other technology, one paradigm will wipe out another paradigm. That is not the way we talk. We should know how to take advantage of it. However, we should not get on into debates, endless debates and discussions on what is to be done, this much top down is enough, that much top down. Assured way we should be able to tell that this is the solution we have provided, it works like this. So, to that extent we are thankful to the definition of certain paradigms which do have commonalities. However, the moment we adopt object oriented analysis and design as a paradigm, we do things like this. It reflects the lessons that we have learnt until object oriented became popular. As a matter of fact, the entire object oriented was known early 50s. Early 50s there have been very good reports, technical reports on object oriented, but until 1990, there is clear 40 years, it was not really catching the eye. And when we latched on to object oriented, we almost wanted to find desperately a solution outside of the structured programming, because structured programming was getting us into the wall very quickly. We are hitting the wall very quickly. So, what is the first problem? How do I identify the objects and model them? That is the way in which we begin this lecture. Object is the most used and abused word in the world of computing today, even today as a matter of fact. 30 years, but we have not stabilized what is an object. Anything can be an object. So, therefore, what is it that we were talking about? We should identify those objects that are significant, that are purposeful and which make together a class. Certain characteristics we need to ensure. If we talk about it, this is an object, the wire is an object, the mouse is an object, the monitor is an object. But then all that I wish to talk about is objects are, there are 2 objects which I am using, mouse and the monitor. All other objects, this is the plus of tasking. This is also the way in which we tell that if I do 20 tasks, my job is over, my functionality is done, I have functioned enough. Can we define tasks with that kind of clarity? These are the moot points which we have been talking. Once again, we have to talk about requirements, we talk about specifications. Are the tasks designable with that kind of precision, that kind of a clarity? Well, we have not been able to. to be candid, 70% of the requirements are volatile, and we are not able to take anything as a firm kind of an approach, saying that this is what it is. Problem solving, this is the end goal of all computing. The traditional approach is to dissect any problem into simpler components, build the simpler component, that is the top down. Key difficulty, we often forget to knit the simpler components together. It is easy to identify 10 smaller components, but which of the 10 smaller components are needed when to complete a task, it does not tell automatically. We will have to figure it out. Is there a way in which it will tell automatically? That is where the paradigm is coming. So, once again it is not to simply go ahead and then keep on debating, but we need to come up with a method to solve, a way of talking about it, a paradigm called object orientation. It is a new way of thinking about problem solving. It inherently permits both dissection and integration, relates easily to the way we perceive the real world. That is how we perceive the real world. We means not the programmers, the people who are actually in the context, who have actually faced the problem, from whom we have abstracted all that, taken it out of the context, defined the problem in a manner where the domain, the multi stakeholders, all of them are couched completely differently, cast it in a language which takes us closer to the machine. The problem will have to begin appearing as 20 steps. It is like that. Wherever we went, it was for some time it is like that, 20 steps to master swimming, 20 steps to bicycling. The bicycle is an example that I have used here. Just ride the bicycle in 20 steps. When you talk to anybody, they keep on telling that unless you fall down 3 times, you will never learn how to do bicycling. That is a fact of life. So, what we talked about is, this is something called a machine bicycle. 20 steps you follow, you will ride the bicycle happily, you will be very happy at the end of riding the bicycle. System development, what is it that we have been talking about is the traditional approach where the analysis and design get roughly 50% of the time, and we keep on doing coding, limited time for testing. In the object oriented, we were able to stretch the design phase. As a matter of fact, it has become a good practice to have 2 design phases, high level design, detailed design. Detailed design is closer to the coding, and we have retained the same time for the testing, but then the design phase has increased, coding phase has decreased. This we thought was a wonderful improvement in the object oriented paradigm, which is very promising, because we know that the fulcrum is not coding in software engineering, it is a design. The fulcrum of your entire exercise is the design, and the more time you spend on design, the better it is. The traditional approach simply did not give us that much time, and therefore, what we did was we found a good balance between coding and the design in this manner, and the design phase is able to increase, and we can talk about high level design and low level design. Object oriented advantages: reusability, easier maintenance, rapid development, improved productivity, seamless in development. How do we look at real world objects? Example is a bicycle. Attributes: frame size, wheel size, gears, materials, operational behavior, shift, move, repair. Now, do we look at bicycle in this many terms and terminologies, or simply get on the bicycle, get a feel for the bicycle and bicycle? Most of us who do bicycling have done the second idea. We do not study the bicycle at all. We do not want to understand the bicycle. Attributes, frame size, wheel size, gears, material, operations, behavior, shift, move, repair. What we do naturally is the way we talk about riding the bicycle, by simply taking on the bicycle and riding it. That feel for the object called bicycle, bigger object called bicycle, and what do you want to do with it is what object oriented assures. So, going back a couple of slides takes a little bit of a time, but it is well worth it. We talked about OO advantages. It relates easily to the way we perceive the real world. I will never think that given a bicycle, I will study the bicycle for a week and then understand what I have studied, comprehend it, get onto the bicycle and take a test drive. We get a feel for the bicycle, we get onto it and go ahead. If I can make this happen, I would have covered a huge cross section of people who take advantage of this artifact as an idea called bicycle. Bicycle has definitely improved the society, it has taken us quite far than what we thought we can. It's a study material by itself, but to ride a bicycle I do not do all that. The impact of the bicycle is a very nice book. There is a good book written published by MIT Press so many years back as to how bicycle has changed things. Many things are like that, but then the point is we think that we should get a feel for this entity called bicycle not through studying the attribute shift, move, repair, but just get on with it and ride the bicycle. Key concepts: classes, clusters of objects that share common behavior. That is the definition of a class. In the earlier lectures, I have taken recourse to using some code segments of C++, which most of you must have been familiar by now, to illustrate that class is like this. It tells that there are certain objects that share a common behavior. So, there are 3 objects here, that is called the lamps. What is a common behavior? There is one switch that puts all the 3 lamps on. You can control, but then ideally one switch that puts all the 3 lamps to glow, and then the recording happens. Inheritance: the ability of a class to pass on attributes and behaviors to its descendants. We do not have to redefine over and over again. If I simply tell that lamp in the studio, it has certain behavior, it has certain attributes, you can close your eyes and use it, it works. Polymorphism: the ability of 2 or more classes to respond to the same message, each in its own way. So, for example, if I have to simply tell whether it is a blue screen or whether it is a green screen or whether the background is violet, the lecture is the same. I am the same lecturer, I am doing the same. Certain cosmetic changes have happened, I am absolutely able to adapt to it. Tomorrow the PowerPoint background will become green. The background behind me may become something else. We may talk about some other background, blue background. There are 2-3 backgrounds here. My good colleagues in the studio will make them happen based on some aesthetic sense which they have been trained to use. So, we talked about classes, we talked about inheritance, we talked about polymorphism, but then what is in my mind? It is an association. Can I identify the objects? Can I find out which is associated to what object? Which objects can automatically get together to give me a bigger exercise? What is the generalization? How many such components can make the big problem solved? Object oriented software engineering. We talked about the similar concerns: specification, rarely complete and correct; analysis, object identification remains the most difficult aspect. That is the lecture today, that is the lecture now. Design, optimization, orientation towards computing techniques. How do I identify the objects? How do I form the associations? How do I form the aggregations? What is the way in which I can generalize? Generalization is the inheritance. So many objects have so much of common things. You get into the next level of inheritance. Object design, modeling, implementation, coding and testing. All these are dependent on the very first step. How do I identify the objects? If I have the task very clearly specified, and if I know a priori what are all the objects that enable me to perform that task, I will simply mechanically go and do that. However, we do not have the luxury at the time of developing the program for the first time, or solving the problem for the first time, or engineering the software for the first time. So, there are a handful of techniques, each has its own difficulties, it is still not a solved problem. Plenty of research is going on how to identify objects, how to identify associations, how to identify aggregates. So, that is how we have been talking about. We shifted the entire discussion into a different paradigm of 15 to 16 different terms very quickly, let us say 20 terms, and in those 20 terms we talk about an idea which banks on a method. You follow the method, you follow these 20 terms, then you are likely to develop good things for a sector of problems which you are solving, for a cross section, for a classification of problems. So, what are these 5? Textual analysis, tangible entities in the application domain, behavioral analysis, scenario analysis, database approach. What is this textual analysis? It is a simple specification. If a customer enters a store with the intention of buying a toy for a child, earlier on we talked about a vending machine with snacks, now you talk about a store buying a toy for a child, then advice must be available within a reasonable time concerning the suitability of the toy for the child. It is not merely calories and the price, but some talking is necessary, some interaction with a salesperson is necessary in a reasonable time concerning the suitability of the toy. This will depend on the age range of the child and the attributes of the toy. If the toy is a dangerous item, then it is unsuitable. How do you know it is a dangerous item? You have to judge, or you classify this is dangerous, this is not dangerous, and why is it in a store, why are you stocking dangerous items. So, depending on the age, depending on certain attributes, we do that. Now, this is a good specification. We are very lucky if people specify in this many nice terms in a language familiar to us. People who have the problem in mind find it very difficult to express what is the problem in a manner where a second fellow understands. If they can do it, it is half solved. A problem well specified is half solved, but then who solves the remaining half? That is the question. So, it's something which we have been trying to do upfront in the requirements and specifications phase, where we would want to express the problem in a manner where we can take it forward like we have attempted, that is, context is off, the problem is now appearing in a different manner and expressed in a completely different manner to take us close to the machine. Is this much of effort worth doing it? Yes, because once it is on the machine, it will keep on doing 1000 times, 20,000 times without sweating, without complaining, without conking off. Anyway, if there is an error, we have a way of finding out what is the error. So, we found that certain things which are so nicely specifiable can be computerized. Will it work along seamlessly with the human? That is the next automation. We have talked about many other things. Textual analysis. The guidelines are simple. You have a part of speech, proper noun, then it is an instance. For example, Rama, it is an instance of a class. Improper noun, it is a class. Doing verb, being verb. Now, the question here is, we have created two different problems. One, you should write the specification in a free flowing English which conforms to very well chosen part of speech. Neither the customer nor any of the stakeholders nor the developers are so good in this natural language called English. We can't identify the parts of speech, we are not so good at it. So, we do not get started at all, or we talk about bringing in people who are normally called non-technical editors or something like that, bring them into the loop. They concentrate on expressing the problem in a manner where the problem appears so nicely defined, so nicely expressed. We will be very lucky, very fortunate if the problem is expressed like this, to find out whether 30% will remain stable or 70% will remain stable. How much will it remain, how much will be stable is also dependent on how well the problem is expressed, and we do not have people who can express the problem so crystal clear in such a crystal clear manner. Proper noun, improper noun, doing verb, being verb, having verb, stative verb, modal verb. Well, we will forget everything, including natural language, computer language, and in our field, whether we like it or not, the pronounced thrust is to take it away from natural language, express it in a manner where everything about our expression takes us closer and closer and closer to the machine called a computer. It is good that we have taken to computerization. You can see the quality of life improving, and now computers are impacting the life. Last 4 or 5 months, without online platforms, without the computerized solutions, we would not have survived this far. The first half of 2020 was such a global disaster, a scare. So, we were able to do that because we were having the technology that is resilient. We could use technology, it is not completely grinding halt, but yes, we are having hope of going to a position where we can spring back. As soon as all this scare is over, we have a positivism that tells us that we can come back, we can bounce back. So, domain specialists, then came the next one, these non-technical editors, non-technical people who are very good in English, but then they do not know anything about the problem or the technology we are talking about. More fight, already we have the stakeholder and the programmer, system designer, analyst fighting. Now, we have one more three dimensional fight will happen. So, we said that this is fine, but then today who is writing such great specifications? It is heaven if you can get a problem specified. This is true at many levels, at software engineering level, at your problem solving level. A problem well specified is half solved. So, we cannot escape the remaining half. You are doing problem solving not to merely specify the problem, you will have to arrive at a solution. So, textual analysis was a nice idea which appeared very straightforward. All that you have to do is look at the problem specification in English, identify the parts of speech. As the parts of speech progresses, you will identify the objects, you will identify the associations, you will identify the aggregates, you will identify everything about the object model, proving to be very difficult. It has not been found very practical, particularly when we are talking about a complexity that runs into 18 volumes of 400 pages. An old Boeing, its specification was 18 volumes of 400 pages each. It becomes very difficult. Can you think of reading a novel which is more than, let us say, 400 pages and remember everything, how it is happening, the English semantics, how it is happening, the concept, yes, we understand, that is easier to get. Domain specialists, then we said that no, we should now understand that in our normal way of solving problems, we removed the dependency on the context. That is fine, because we wanted to make it context free, it works on my desk, on my machine, then we will push it back into the context, we get more genericity, we find out in how many places the same problem is occurring. That is how we build more and more complexity. Can we do away with the domain? Initially it was like that. We are neither concerned about the stakeholders nor concerned about the domain. We want the problem specification in a manner where it is more and more appealing to take it further down into a language which pushes it into the machine. Who knows, computing will automatically relate to the domain or not? Nobody knows. Are we wanting it to? Nobody knows. Irrespective of the domain, irrespective of the multi-stakeholder, it is just 30 instructions. You follow these instructions, your problem is solved. Now, this did not take us far. As I said, the time of reckoning came, first time when we seriously reckoned in 1996, our success rate was only 16%, 16%. Nowhere in comparison with other engineering disciplines that have evolved over centuries, matured over hundreds of years, and their success rate is 99.99999. We are just 16%, that is where the challenge is. Now, we are at 36%. In next 20 years, we showed 20% increase and lot of software projects. It is a huge number. Wherever you go, there is software. Across so many software projects, 36% is a good number, good enough number to challenge or to be listed alongside other engineering marvels or other engineering wonders. Key problems: extracting the knowledge of the specialist, relating to computing, and multiple experts. So, what we did is simple. We said, let us not forego the domain, because the domain is automatically going to tell you what are the objects, how they relate. Who will tell us about the domain? The computer fellow will not learn other domain, like they have been resisting. We do not want to learn computing. Who will do that? The domain expert. Now, the domain expert has a different problem. He has the knowledge, but then who will extract it? We had these problems earlier on. We did not want to talk about the domain, but then in the field of artificial intelligence, we created one other nice term called expert. He is an expert in this area. The domain may be larger domain, but it can, health is a domain, Heart is a specialty, heart expert in heart. These days, everywhere you go we are talking about health. The domain is healthcare. We have a specialist or an expert in heart, lungs, nose, eyes, like that we keep on talking about. Now, that expert is so nice that he has his knowledge in the head, but who will bring it out? When will it come out? For example, you talk to a doctor, he is not simply doing lecturing. You go and make an appointment and talk about an ailment, then the knowledge will come out as a healing method. Otherwise, why will he tell this much I know, it can happen, anyone who has a nose can have a common cold, as long as you have a nose you can get common cold. That is not the way we talk about experts or specialists. Relating to the computing, not only that, he should relate everything to the computing. Next, in every given domain multiple experts will be there, no two experts concur. Behavioral analysis, then we said that it is becoming very difficult to catch the experts, put them together, get the knowledge. We have had difficulties. It was promising, every area was promising up to a point. That up to a point was very stimulating. We have introduced courses on expert systems, projects happened on expert systems, but once the summit has been reached, we do not have any other serious solution, because the human expert is a human expert. That is how it is. Data flow diagrams is the next idea, that is behavioral analysis. Let us not talk about the domain, we talk about the behavior. What is it that you are expecting out of this system? If you are giving me this, it should transform it into this. That is the minimum behavior, well defined input, well defined output. If I can tell, I can understand, I can imagine, I can visualize what is that function f, which is called behavior, that transforms the input into well defined input into a well defined output. So, you have an apple, I am telling that the well defined input is an apple. What is the well defined output? Cut into 10 pieces. Can I understand the behavior or not? The answer is yes. It is just that I have to find a tool to cut it. Here computing transforms in a different way. What will we look for? We will look for a nice knife and we will mark 10 pieces. If it is a simple problem that it can be cut into any number of pieces, we do not even have to worry. We can simply cut. If it is 10 pieces, 10 exactly similar pieces, these are all the challenges which we can talk about. So, given the input, well defined input, well defined output, we can roughly imagine, we will figure it out what should be done to convert this into just like a puzzle, fill up the blank. You have all the words except one word, that is a blank. Are you able to guess the blank or not? The answer is yes, you should know how to fill up the blank. Geometric analogy problem solvers, A is to B is as to C is to question mark. So, the point is, these are all the behavioral analysis kind of ideas which we have been accustomed to in some way of problem solving. However, it is a strong methodology evolved because of the structured programming, well defined input, well defined output, and you please figure out what can happen in the middle. So, it is a traditional structured approach which reflects top down. So far what we have done is, we have realized that object identification is a very big problem, and that is the first step in object oriented analysis and design. If you can't identify objects, if you can't model them properly, it won't succeed. After modeling also, we still have to debate back and forth on so many things. So, in the next lecture, we will see more ideas. Out of 5, we have seen textual analysis, domain specialist, behavioral analysis. 2 more we will look at it. If we think that we are comfortable with this handful of ideas, we will identify objects, aggregates, associations, generalizations, inheritance, polymorphism, data encapsulation, then move to a method that tells us cohesion, coupling, many other things, reusability, communication. All those 20 terms will become a paradigm, and very soon we will be using this paradigm to solve more complex problems. Thank you. We will see in the next lecture.